Right, let's see if that's a bit faster. Cool. So what do I want to do? We take, let's have a look at this. So ideally when this is together, so this is going to be the movable parts using your wrist like that. Ideally what we want is, I believe, 90 degrees of motion. So the gear's going to go here, and after 90 degrees of rotation there, we need a way of it stopping. And if that happens in the mechanism itself, that makes things easier. So what I'm thinking is, if we take this cog and we basically delete 180 degrees of teeth, if I've got that right, it should mean that it will travel. Which way will it travel? So we have that. Let's just get a marker out. Blah, 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 blah. Okay, so let's mark the teeth. Let's mark that one there. We'll mark some teeth on there. Right. And we want 90 degrees of travel. So if we start here, that's going to be mounted to the bottom of the bar. And then we're going, so we're starting from there, and we want to work around 90 degrees, which will be around there. Let's just mark that on here. Again, we're starting from around there. It's now going to move 90 degrees of travel. So really we might think we need 90 degrees plus an extra tooth. Let's just try that again. So that's bound kind of to an extra tooth. If we were to just block that there, that would be a problem. But if we say 90 plus an extra tooth, and then we go round, that's good. But again, yeah, that extra tooth there. So we can bind into there. That should be fine, shouldn't it? So I think if we take the 90 degrees and have these teeth plus 1, so if we cut across there and cut across, ooh, that's going to go into there. Let's cut across here. We then need a solid section and a solid section there. I'm just going to move this for a sec. So we have our 90 degrees plus an extra tooth, and then a solid section, which, so the idea of a solid section is the teeth will just bind onto it. So that will be the hard stop. I think that'll work, who knows? And then we can delete the teeth up here. And what that will allow, in theory, let's just pop that on the other side just so I can see what I'm going to be doing. So that's going to come through there. That's going to come through around there. So this is going to be the upper edge. So that's going to be the upper edge. Now, if we were to put that into the bottom mount and say that's the upper edge, how much play do we actually have? So, we'll take this and then we'll go. So say that if this is the 0 stop, we then want to rotate around to 90. So that's going to give us 90 degrees of motion there. What I'm trying to answer is how many teeth can I delete, and can I make this profile a bit smaller? What I might do to start with is just to print the cog with less teeth. And then we'll see if it works. And then we'll faff around with this outer shroud. Because we could make that thinner around the top edge, which will make the profile a bit nicer, but I don't know whether this will work. So what we'll do, let's look at the teeth first, and we'll try and delete some teeth off of this object. So in FreeCAD, this will be called the grip gear. So we have a grip bit here. In real life, it'll be a bit longer after I print the whole thing, but I just sliced it off just so we could print less. So essentially, we'll grip around there. That will drive the cog. This will sit underneath it, which I'll show you in the CAD. And then this bar will join it onto this motor, and also a rotary encoder at the other end of the collective shaft. So what we'll try and do now is we want these 90 degrees worth of teeth. We want a bit of solid, and then deleting the rest of the teeth, which might be fun. So let's have a look at that in FreeCAD then. So we have this gear here, and if I just show you that shroud there, so that's what the shroud would currently look like if we just remove the top cover. You see this is the black part that I was just holding, and then this is the controller. And this is how they will mesh, and then what that will ultimately look like if we zoom out is, where's that axis coming from? There you go, get rid of that origin. This is the collective bar, which is a 2020 extrusion. And then this is basically rotating around the bar. And then we need to solve this today as well. How are we going to mount the motor onto the bar, which will then ultimately drive this? This is going to get a bit tricky. We want this to be controlled by the pilot, but equally in helicopters, the governor also controls the throttle. So this bar is going to be kind of the input axis, and then we're going to have the motor driving this bar, and it will need to slip in some way, basically because the pilot will need to override it. So if the pilot wants 0 throttle, this bar is going to move, and if the motor's doing something else, it just needs to slip and let the input work. We'll see if Flight Sim actually allows us to do that nicely afterwards. Otherwise, we're going to have to get a bit nitty gritty in the software. But this is fine for now. It'll at least give us kind of that force feedback feel, which would be really cool, because this throttle quadrant will basically, in normal flight, be moving by itself as the helicopter governor changes the engine throttle, changes the RPM. This will essentially be moving backwards and forwards based on what's happening in the simulator. So let's have a look at this part. What I'm going to do is I'm using FreeCAD 1.1.1, no, 1.1.0, which is a lot better than 1.0, and comes with some nice improvements. So let's just hide the bar. We'll keep this, and we'll hide the top stop and bottom stop. Okay. So I'm going to work off this face, and we'll just hide this mount as well. Now I'm not going to go back in time and edit this gear at all, because the gears are pretty primitive based on, you can fill these out, but you can't really set much else. So I'm going to leave that there in the tree, and then I'm going to either cut or pad based on what changes I want to make. So what we'll do, we'll assume this is currently at 50%. We could either do it at 50% and then do a 45 arc here. That's probably going to be easiest, because it'll let us align with the axes. So what my plan is here is, so I'm going to do a 45 there. We can then delete everything here, and then we'll go in and add the end stops. I think is probably the most sensible approach here. So I'm going to click on the face, go new sketch. Hello, cool. Thanks for joining. And first we need to activate the body. So here we can see the axis. It does help if you align things around the central axis. Sometimes you might do a sketch where you start out this way, which then becomes annoying because you don't know your midpoint. So what we can do, let's just draw a line out here to start with, and then we'll draw a line here, and I'm holding down Control there just to get some constraints in, and we can see they are well, we'll play with constraints in a second. So we're clicking the axis there, and we want 45? Yes, we want 45 degrees there, and we want 45 degrees to that angle there. Okay. What we might be able to do is, if we bring up the projection tool, let's just make that available there. So the projection tool is pretty useful. Let's just project that, and we'll turn that into a construction line. So in FreeCAD 1, you can't, a projected line can't be part of the sketch itself, which is a pain in the arse. In something like Fusion 360, you can project and then you can instantly craft off that line. They fixed that in FreeCAD 1.1, where you can now take a projected line and then turn it into an actual line that will cause an extrusion or a pad. So that's a nice feature. it threw me off the first time because you do have to be aware of the state of a construction line or the state of a projected line. And you can make it a construction line, which in some cases is great. In other cases, you want it to be a line that is part of a sketch. So we'll have a construction line to start with, and I'll show you why. To be fair, we probably only need 1 point. Actually, I'm not going to do that. Let's just delete that, because we can, for our initial cut, we can be a bit more crude. So we're going to have to, yeah. Okay, so what we'll say is we're going to start from this line and we're going to go all the way around to here. Now we do need an internal diameter, which we can get from this line on this other side of a sketch. So we should be able to project that because it's the same part of the body. And then when we go around to this side, we can see that we have that line there. What I'm then going to do is I should be able to trim that line. So I don't know whether we might need to split the edge. Let's have a look. And can you do it on a projected line? Okay, that's fine. So what we can do is let's just realign our sketch again. So we'll take another arc, and I'm just going to put it there to start with, and we're going to go round and put it there, and I'm going to change this to a construction line, blip 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 blip, something like that. And then I'm going to say this is a, where are all my constraints gone? So we're going to say this is should be a tangent. That should be fine. So if we move this, yeah, we can see it's constrained, but it can still move around this way. So that's fine. So that's now a tangent to this projected line. So if we were to change the dimensions, that should mostly stay. And then we'll do a coincidence onto that line. And then we'll come over here. And this is the reason why I didn't click it directly, is because sometimes it will try and assume what constraints. Sometimes that's fine. Sometimes that's quite annoying. Cool. So what we're trying to sketch is a green box over the parts we want to delete. I do wonder, we wanted 45 degrees, but we also said, based on this, that we want an extra tooth. So we'll count the teeth in a second, but what I think we want to do is let's finalize this sketch and then we'll just have a play with the angles here. So what we can say is let's do a dimension. And that's getting upset. Why is that getting upset? Okay, well, let's do a dimension from there to there. That should be no. Okay, what we could do, let's take that and bind that to there. And then we'll take this edge and we'll give that a length of, let's say 20. Way too small. 35, nope, 30. Okay, cool. And then we'll do the same here. So we'll take that point and that point, and we'll do a coincident. Now, when you're working in the sketch tool and you're working with constraints, these red parts here, if you want to unselect, it's right click. Now that took me a while to learn. I'll constantly be hitting escape and then it will come out this sketch and it'll be a pain in the ass. But if you're working with constraints, yeah, right click and it unselects, which is quite nice. Okay, so we can see we have some partial constraints. Let's try and delete this and see what happens. Yeah, and then it says, oh no, I need to be more constrained. Useful. Let's try that again. Well, actually, what we could do, we could take up, or not, we could take this and make it coincident onto that, and that will work. There you go. So ideally, your sketches should be fully constrained. I believe in previous versions it was actually a requirement. I might be wrong on that, but um, it's generally best that they are constrained. Otherwise, weird things can happen. I mean, even weird things can happen in fully constrained FreeCAD sketches. Um, Basically, if you have let's say a this type of dimension, it doesn't actually have like a positive or negative to it. And I believe unless it refers to an axis, if I were to say take this and make something out here and make that 30 millimeters this way, and then I were to make a major change, sometimes the sketch solver will flip it onto the other side. So it'll be now 30 millimeters this way, which is a bit of a pain in the ass. Apparently, if you just do it around axes, that's not so much of a problem. So, well, yeah. Or you do small changes. So if you like move something by 5 mil, by 5 mil, by 5 mil, then the solver doesn't get confused. And yeah, it generally works. You could, if you notice things like that, you can always undo it and then try again. But really, with FreeCAD, just have an itchy Control S finger and keep things. When you're happy with something, save it and hope for the best. So we have this sketch, and what we want to do now is, I mentioned that we need a certain amount of teeth. Yeah, so let's have a look at that first, actually. So if we have a look here, we need, we were happy, so we're going to 1, 2, 3, 4, 5, 6, 7, 8 teeth, I think we want. And then we're going to make a solid zone. So we'll do the solid zone after this, but we want 8 teeth. So let's just put back to the sketch and see if we've done that or if we screwed up. So what we have is one moment. So we have we have how many? Oh, I said 8, didn't I? So 1, 2, 3, 4, 5, 6, 7. Does 8 work? That's a bit weird, isn't it? So we have 45 degrees. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, fuck it. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So let's just start. What we could do, let's not do that, and we'll just have a single angle between these two. Here we go. 1, 2, 3, 4, 5, 6, 7. So that's going to give us Why do we want 8? Hmm. Well, I'm not convinced we want 8. Because if it was equal, then it would be giving us 9. Okay, well, let's put back to this and try and work out how many teeth we need. So we need that spare tooth, right? Where that's just going in there, we kind of need that. Otherwise, it's going to get blocked up here. Actually, let's assume it's blocked. So we need that one, 1, 2, 3, 4, 5, 6. Right, like this. So assuming it's blocked, we have 1 tooth there, 2, 3, 4, 5, 6. And how much motion is that actually giving us? So if this is, let's say that's fully down, we have that, but we're assuming the tooth is blocked. And we're going to go 1, 2, 3, 4, 5, 6. Yeah, see, we need 7. Let's try again. So that one's blocked. We're saying 1. This is down. 1, 2, 3, 4, 5, 6, 7, 8. Let's just do 8. And we'll see if it's wrong. I'm sure there's some nice mathematical way of working this out, but I have no idea what it is. So what I'm going to do is I'm going to constrain that, not there, constrain that to there, just so this one doesn't move. And I'm going to say 1, 2, 3, 4, 5, 6, 7. And I say 130. Nope. 150. Nope. 140. Nope. Oh, just undo that. 140. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's give that a go. So now we're going to pocket. And you can have a pocket that way. It's currently going the wrong way, isn't it? Where's the pocket gone? Ah. So this line here needs to be a construction line. That's what would be nice is if you could split a vertice. You can do this split edge and then change this to a construction line and then merge these as coincidence like that. A bit annoying because then it starts to lose different, doesn't keep it as okay, so we'll make that collinear. Yeah, whatever. Yeah. Okay, now we'll do the same over here. A bit annoying, but it's what it is. coincident that. Maybe there's a better way of doing that. And then we'll make that there, and then we'll make that collinear to that. Okay, cool. So now when we close this, we should see, yeah, so we just have now a single solid shape there. Cool. So what we can do is we can now pocket that, and that should start working. Okay, cool. This is a update in FreeCAD 1.1. Very nice. It will show you what it wants to do. Not sure if the other versions actually had that, but this seems to work pretty well. And it will actually show you how it's going to delete that against the body. And I realize I haven't changed that. So this is going to give you that cutout. It's pretty good. You can also do a to face. So what I'm going to do is I'm going to say up to face. Actually, let's just try to first. I'm not convinced that's actually made a difference there, has it? We could say up to face and select that face, or we could do a dimension. I'm just going to do dimension actually. Sometimes in FreeCAD, if you were to go back up here and change something, it would then recompute all the face numbers, and then it would just break lots of crap. So, okay, so let's have a look at this again now. So we have 1, 2, 3, 4, 5, 6, 7, 8 teeth. And we included these last teeth as kind of blockers, right? So currently the gear would mesh around this tooth. I think all we kind of need to do is just extend these out to be kind of the end stops. And then that should give us, well, it might work. So what we'll do, let's do another sketch on here. And then we can project this, and we can project what's the best way of doing this? If we project this and just kind of we could kind of bring that up, couldn't we? If we were to cut less out of it in the previous sketch, we could then kind of just draw a box around this. Let's see if we could do that. So I'm going to just go back into the previous sketch here. Let's just delete these constraints because they're kind of annoying. And we'll just decide where we want the lines. And we want that line there. And then we'll put the constraint back in. And now it's going to go, no, can't do that. Okay, cool. So just line that up. And then we just need to constrain it against a axis. So it's fully constrained. There you go. And now we'll go back into here. Okay, so the reason I did that is because then it gives us some features to actually work off. So what we could say is I want to project this line, nice, and this line. And then we can go back. We basically just want to fill this in though, don't we? So maybe we just do something like that. We delete that. Let's just look at it face on. Oh, we don't actually need that, do we? So if this then comes up, do we draw a, yeah, go on. Let's draw a construction line around here. So we'll do a construction line, make it coincident into that. Nice. So we can then do something that looks a bit like that. Cool. If you zoom in, the constraint exists. I don't know whether this is a bug of this version. The constraint exists, but it doesn't quite line up. Oh well. And then actually what we'll do, let's make this a construction projection. Okay. And then we'll make this collinear. Cool. So that's kind of going up at an angle, which is the same angle as the, yeah, as the circle, I guess. And then we should probably then draw an arc between these 2 points. We don't actually, yeah, let's leave that in for the reference. And then we'll make an arc. So we'll go a midpoint. We'll go from there to that one. There you go. And we will turn that into a boundary line. Okay. And this is, wow. Coincident, please. And then we'll do the same here. Coincident, please. Okay. What the fuck? Okay, so and make that coincident. This is a bit of a pain. Okay, so it's still saying something can move. Okay, that hasn't. So this is why sometimes it helps to be explicit in your constraints, because if you try and click, you kind of have to wait for the symbol, for correct symbols to appear, and if you don't, it's going to punish you by not actually joining things together, and then it won't be constrained. So we'll just do 1 tooth, pad that out. I think we said it was 8 mil. Let's have a look down here. Okay, that's in the wrong direction, so we'll just reverse that. Looks okay. Okay. So the idea here is that when the tooth comes round, it won't be able to mesh. That looks pretty good. I'm pretty happy with that. So what we'll do the same on this edge now. And what you'll find when you're doing these things is it becomes a lot quicker once you know what you want to do. So you know, if you screw something up, it's actually not too bad to go back and do it again. It takes you considerably less time than doing something from scratch. It's always a bit slower doing something from scratch. Okay, so we want that there. We're going to draw a line, and we're going to see that kind of pop up there. That's what we're looking for. And then we're going to wait for the pop up there for the tangent. And then, you know, it's another tactic is you put it out to something noticeable like that. Then you can click, make it collinear, and then it forces the it, and you can see it's constrained, which is nice. So let's make an arc again. So we're going to make an arc. Wait until we get those constraint points. Wait till we get that constraint point, and we got that constraint point there. And it's there you go. So redundant constraint is not an auto constraint. No auto constraints or additional constraints were added. Please report. Okay, so that's what happened last time. Fine, classic. So let's just add these in manually. So, and that one's going to go there. Okay, and then we can see the constraints here. So I'm just going to highlight those and constrain them. Cool. So now we have 2 sketches basically doing those edges there. So the idea is this should give us around 90 degrees of rotation before it basically binds on the end. I think that should work nicely. So if we bring back the bottom stop here, what we could try is bind these gears in an assembly and actually rotate them in FreeCAD. We could try that. I feel that's going to be a painful experience. But the idea here is that if this rotates around the central axis here, it's going to bind here, and then 90 degrees around it's going to bind there. So, and if we want to change that, it should be relatively straightforward. It might get a bit upset that we're using these as projections, but we'll cross that bridge when we come to it. I think this kind of works for now. Let's just save that there, and I'm just going to do a transform and just rotate this just so we can quickly visualize without making it a proper assembly. So we're going to rotate round. And we're pretty much going to get to there. Yeah, so I mean, this kind of goes up a bit too high. My idea was, oh, we could trim out kind of 180 degrees of it, right? But you could only really trim out this top part, so it doesn't really make much sense to try and optimize that yet. So that's down there, and if we're moving 90 degrees, we should then have it face up there. So yeah, that should give us 90 degrees of motion, shouldn't it? So I'm looking at this V-axis here, and as I rotate it, it's giving 90 degrees of twist before. It might be just over. That's perfect. I'm not that fussed about that. Around 90 degrees will be perfectly fine. So that should work. I'm pretty happy with that. And we should get those bind stoppings. Cool. Okay, so let's just cancel that. And then we can add back in everything else here. Okay, so what we have is we have this. I'm not going to print this cover. Well, yeah, I'm not going to print this cover yet. All we've changed actually is this is the grip itself. So that should be quite an easy reprint just to check that that bit works. I guess what I haven't quite worked out is what the ideal spacing between, let's just have a look at it at this end on, the ideal spacing between kind of the center axis here and what our 5mm bar is going to be. It's, if we have a look at, let me just bring this. So this is kind of a 5mm rod we have. It is stainless steel, and it doesn't really bend. So the question is, do we need to support it between, well, we're going to have some support for it. Primarily, we need some support around here because it's going to bend if we just support it 50 centimeters that way. It's not going to mesh properly. So we need some support to, we have a bearing. We've got some 685 ZZ bearings. So that will go round the shaft. But we do need to make something to support this for the meshing. I doubt we need intermediate supports. Just based on the length, it should be okay. But yeah, we do need something here to work on. So the question's going to be, how meshy do we want it? I mean, this might be something. Yeah, it's probably a bit far out there. So we do currently have a joint that is that. So what we could do, let's just try and move the rod up a bit. So it's going to be too much, isn't it? Let's just do that and we'll see if we adjust this joint. Yeah, so it's really like, it's half a mil difference, isn't it? If we move it down half a mil, and we'll just refresh that joint. Might be right. Okay. I don't think it's not going to matter too much, and I'd rather it be slightly loose than too tight because there's not a lot of friction in this mechanism. So what we can try and do is, where's my, I'm trying to transform the wrong thing there. We're going to take the rod. Let's put it back 0.5. There you go. And what that will allow is for a bit of play if we need it. That should be fine. So let's so there's a bit of looseness there. That'll be fine. If not, we can always adjust it. Let's just have a look at it end on here. So this could be a bit of a pain. What spacing do we have between the bar and there? So with a 2020 extrusion, I'll just show you on the camera here. You basically have these little rails that you can put nuts in. So exactly down the center of this bar, we can fix on a nut and a screw, and then have something hang down and have the bearing around it there. So let's have a look at that. So what I want to know is the distance we have between these two objects, because it's going to affect how we, actually it doesn't matter, does it? We could screw it on and then push the bar in. Yeah, so yeah, it doesn't really matter. So let's take the bearing here. So we have a bearing. And before we do anything, we'll just check it fits the bar. So it's going to fit the bar. This is going to go on the end. And we need to take a look at this because I seem to have got the whole dimension wrong. And then it's going to sit in there and rotate. And this is just going to support it. So what we'll take a look at first then is let's actually, before we forget, let's just fix the hole we have in here, because we said, and you can right click, toggle section view. Interesting. Okay, let's just pop back in time. Let's just hide the rod for a second. So we do a pocket based on a sketch. It's based on something that's projected. Okay. And that projection comes from I'm wondering why we projected that. Is it because we did it up here first? Seems a bit weird, doesn't it? So what does this? This hole should be this fabricated hole there. Yeah, there we go. Okay, so this line here, is that part of the pad? Okay, here we go. So we've set that to 5 mil. However, on the print, it's come out to like 4.9. Now, what I find with, I probably should have made that kind of like 5.1, and then it'll come out decently enough. So let's make this 5.1. That should be fine. And then this is fixed to it, so we don't need any bearings or anything in there. We can then show this, and we'll just click it here, and here we go. We can check for diameter is 5.1. It's always good just to double check the projections are working. Okay, well, hopefully that will now work. So we need to print basically both the gears again. I'm just going to make a note of that because so we want to print the gears. And then we're going to take a bar of this rod. There you go. That's going to go in with a grub screw. Fine. And what we want to find out is if we hide the motor sensor mount, we need to find out the distance between that and the central axis, or the main axis on here, or here. That'll be fine. So let's get the measure tool out and fight with this. So that's going to be halfway, isn't it? If we do a distance between there and there, maybe? Nope. What about a distance 3 between there and there? Nope. Okay, a distance between there and an edge? Nope. What I'm trying to get is the components. Okay, between that edge and there. Doesn't really help. Here we go. Cool. Okay, so I think we know it's 29 from there to the bottom edge. So that's going to give us, I'm just going to draw a diagram here. So we have from the middle down to the bottom edge. So we'll start off with something that's 35 high, and it can be 20 mil wide. So these extrusions are 20 mil by 20 mil. It doesn't need to be any wider than that. This is pretty small. And this to the top of the bar is 29. We're going to have a bit of a padding here so we can secure it down using a screw. Okay, so we should be able to do this with, it's going to be a flat plate. The bearing's going to have to go in the middle. How thick is the bearing? So the bearing itself is 5 mil. Okay, so the bearing is 5 mil deep, which means we want probably like a 10 mil thickness. I think that's probably good to start. So what I'm going to do, let's go over here and we will make a new part. And we'll just get rid of this measurement tool. Let's just save it. Okay, so what we'll do, let's make a new part. We need the part design workbench. We'll make a new part and we'll call this rod bearing mount, very original. And let's make a new sketch. Awesome. So this sketch actually quite nicely lines up. So we can double check our measurements in a second. We'll start here and then we'll move it. Yeah, let's do that. So we want it to be 20 by 20. We're not going to use these sketches, otherwise it'll get very confusing. So we know something like that, right? It's going to be 20 mil there. We said let's start with a height of 35. Cool. And we're extruding kind of the main face for it first. So it's 20 by 35. You can see we haven't constrained it yet. Now what we can do is we should be able to select this point, and the center origin, and then we'll do a symmetry constraint. And now we have a constrained sketch to the origin. So the next part would be the bearing. Again, so this is actually 10 mil off at the moment, but we'll fix that in a second. The next part is the bearing, which needs to go is 29 to the top of the rod. Okay, we'll do. Let's put the bearing in, and if I measure the bearing, it's 11 mil. So let's go with 11.1 for the outside of the bearing. And actually, the bearing, the thickness of this can be 5 mil. We'll see what the bolt thinks about that in a second. But we'll do that. And we'll do that to there, which is 29. Interesting. Let's make this 40. Okay, let's go with that to start with. So we'll pad that out. We can make that 5 mil. Cool. And now what I'm going to do is we're going to transform. We're going to move it along, and we'll move it up just to give us a visual indication of what's happening. Oh, okay, so that looks pretty nice. We still need a way of fixing it to the bar itself. The bearing would be press fitted inside there. I mean, there's not going to be really any loads against this. It's literally going to rotate, and it just needs a bit of guidance. So let's just go with that to start with. We need a way of fixing it to the bar. So if we come out with just a right angle, I think would be more than suitable. And in the middle of that right angle, we'll then just drive a screw down. I don't really see much other purpose. Do we need? I think let's just do it on. Let's just do one side, and then we can print it on this flat face. and print up, and that should be fine for this. So what we can do is let's start on this face here. We'll just give that a slight angle just so we can do some projections. Let's project this line. And then we want to do some profile sketches. So we'll project this as construction lines. And then we'll come across holding control to keep it. And then join that up to there and join that up to there. Okay. So we have a bit of movement there, perfectly fine. And we'll set the constraint there to be, probably 3 mil is fine. Okay. It's saying this can move. Yeah, look, so it missed a constraint there. Yeah, it does take a bit of getting used to the sketcher. Let's say newer versions are better. Okay, so 10 mil, that should be fine there. And then we'll do a new sketch on there. Let's just hide the bar for a second. So, oh, not that bar, the other bar, the rod. We can put this in here as a 5.2 hole should be fine. Where should we put it is the question. Again, we're using the axis for kind of the midpoint, and we kind of want it in the middle of those two lines, don't we? Yeah. So let's do a projection between there and there. These need to be construction lines, otherwise it'll get very upset. And then we can do a symmetry constraint, hopefully, here. Okay, I think we need to use with points here. A point there, point there, point there, symmetry. It's doing no, that's completely wrong. Okay. How about point, 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 symmetry? So we have a constraint, which is a size. We have a constraint on the axis. Okay. Sometimes it's easier just not to be smart, and we'll just throw this in at 5 now. Whatever. Fine. Okay, and then we'll pocket that down. So we don't need a threaded hole for this. We'll use the bolt of the right height, I think. And we'll pocket that down through. Okay, so the bolt's going to go through there into the middle of the V-bar. If we now show the rod, we can move this. We'll just transform that. We'll just throw it over this way. There you go. So that's going to kind of be our support there. The bearing's just going to press into that. The bearing is 5 mil, so that'll work nicely. And then we're going to push up into here. Let's actually make this. 1 second. I'm just going to check what bolts I have. Yeah, so we either have M5 times 10s or M5 times 12s. What I want to check is if we measure how much freedom do we have, like Just do some measurements. What way up? What way up does it go? That way. So we have around 9 mil. So we can make. So the thing with screwing into these V-bars is if your bolt's too long, it then kind of pushes back against itself, which is it's a bit annoying. Okay, so if I use an M10, I should be able to get around 5 mil. So what we'll do, let's actually change this. Let's change the height of this to be 5 mil. And then when we put a bolt in there, we're going to have 5 mil plus 5 mil of the bolt, I guess. Yeah, the bolt's 4.5 mil, so that should work quite nicely. We used M10s for that. Okay, then, so so we have that there. We have a way of now supporting this mechanism on the bar, and we fixed, we have kind of 90 degrees of action there. So I'm pretty happy with that. Now, this is, I wonder, we kind of want to make we want to make another instance of this, but I don't really want to, we kind of need to like make a dependent copy, don't we? What we'll do, let's give it a nice little car. Yeah, come on, something totally different, please. No. So I guess while we're here, let's add a little fillet onto that as well. Nice. So we kind of want to copy this. I don't want to redo that, but it would be good if it was linked. So if I made any changes to this design, then it would be reflected over here. And initially I was considering, oh, maybe I could just put a bearing in this mechanism and mount a sensor on the back of here. However, if I screw up this height, I will then need to reprint this, which is kind of annoying, right? So what I'm thinking of doing is these brackets, they're pretty small, easy to print, easy to adjust. So we can mount the sensor on the front of this edge and have the bar kind of stop here, and we can have another rod bearing mount here. And that means that if this is slightly off, it's not going to be the end of the world. And it means that we don't then, if we do get this measurement wrong and these don't bind properly or they bind too much, it means we don't need to print off this and probably another one. We just need to adjust these two. And to be fair, we could even just shim it out add something in here between this joint and shim it out by 2 or 3 mil. If we were to do it this way, we would need to print this entire thing off again. So I think I'm happy with the idea that we'll do that. So we have this mechanism here. Yeah, so what we want to do is we want to copy this. So I think we probably need to consult the manual of sorts. So we want to do FreeCAD, what is it, duplicate part reference. So if it was a body in a different sketch, I think that'd be fine. A part design clone creates a dependent exact copy of a body or feature. So what we could say is if we do that, we do part design clone. Oh, here we go. Okay, and then we can move a clone out, and we probably want it facing the other way for this one. So let's do something like that. Let's reposition the camera there. So, okay, awesome. So we have this, and if we have a look at body 10, we can see it's a clone. Hopefully that will update. So we'll say that is the motor sensor rod bearing mount. Terrible naming. But that's now over here. Cool. And we'll bring it into the assembly just so we don't forget about it. Okay. That's interesting. That is very interesting. We seem to have switched them round. That's not useful, is it? Okay. Oh, let's just undone the, let's just redo the fillet there. Oh. Rod bearing mount. Did I not? Ah, it's okay. Fine. Let's just redo that. Oh, goodness. Let's redo this fillet. Ugh. So we're going to increase this here. Yeah, that'll do. Okay. We're then going to select this here. We're going to go part design, clone. Let's be quite explicit. Okay. Right. The object origin is weird. Why is the object origin all the way down there? That's a bit annoying. Okay. Well, hopefully this will work for the rotation, won't it? Then we'll just put minus 180 in there. Yeah, that should be fine. Weird. Cool. So we have, put that in there. Okay. So now we have a cog. We have this cog going through 2 mounts to this part. And this is now adjustable, and kind of this is adjustable as well, which is quite nice. It means that you can play around with tolerances. What you a trap I've kind of fallen into before is if you spend too much time just modeling something, you can then end up trying to make it all, and in real life it doesn't really fit together. So keeping those iterations quite snappy is always useful. If you feel that you've you basically don't want to spend 2 weeks trying to design something, because you'll then kind of be in the integration hell side of things when you come to print it off and you have 100 pieces and none of them fit together. So using bits like this to give you that freedom to screw up is useful. A lot of the prints I end up doing will mostly work, and if they don't work, it might just be, oh, I need to drill this out, but they will mostly fit, and then it might just be a couple of tweaks to go back in and, okay, well, it would be better if it was like this. And saying that, actually, we could put a fillet on there, move this bolt over maybe a bit, but functionally that's going to work fine. It's not going to have much load on it, so I'm not too concerned about that. So we have this rod. Now this rod is probably a bit bit too long now, isn't it? So we'll do, let's get the measure tool out, and we're going to measure from this face. We'll just hide the motor sensor mount, measure to this face. And it's going to say, no, that's not how you do that. We want to measure from this face to this face. No. Oh, try again. From here to here. Okay, so it's like 270, isn't it? Let's say 275. So if a rod were to be 275, in real life it might be longer. Doesn't really matter. I have a 500 rod, but for the design purposes, we'll make it 275. So let's go back up and have a look at the rod. We can see this pad here. Let's make that 275. Cool. That's kind of worked exactly how I wanted it to. We can then edit this. Okay. So this motor sensor mount, and we're going to call this rod bearing motor end. This motor sensor mount, I'm just going to move that down in the tree, just so there's a bit of an ordering to where things sit in the model. So you can kind of see what I'm trying to do collective wise now. There'll be another handle on here. I think this end, so you don't conflict with the bar. So you'd move your hand down onto the throttle, which I think will be fine. Again, it's creative license, I guess. It'll just be nice if it mostly works. So this is going to run down. It's going to go through these two joints. And then it's going to have a magnet on the end. And we're going to use an AS5600 to measure the rotation of the bar. Works pretty well. The AS5600 can do a 360 degrees angular measurement, and it uses a diametric magnet where the magnetism it's kind of the wrong way around, isn't it? So you would think of like a magnet, the flat faces, are the north and south, but with a diametric magnet, north is on, it's around the curve, north is on one edge and south is on the other edge. So as you rotate it, you can measure the angular or the magnetic displacement or whatever fancy things that is. So what that allows us to do is if we stick a magnet on the end of this bar and have a sensor aligned at the end of the bar, we can measure how much the bar rotates. Similar to, we could stick it to a potentiometer, right? But yeah, let's not do that, and we'll use the magnetic approach. It's really not that much more complicated. Okay, so I think I'm happy here. I'm happy here. What might be nice, we could print these parts. I might just do that at the end. Let's try and work on this. So I'm just going to have a quick break, and then when we come back, we will pop this motor onto here. We'll have a motor come through here. Now, something I've forgotten about is we actually need to drive this from the motor. So we need to see how much play we have. So we're going to use is it a GT2? Is that what name escapes me? I'm going to use a 2GT timing belt. And basically the motor needs to come through. The motor needs to be adjustable, and we'll use this somewhat slot design to adjust for tension in the motor, or in the belt itself. So we can move the motor up and down, and that'll adjust for tension. And what we'll do initially is that tension will be the slipping mechanism. I don't know how well that will work, but it's something easy to try to start with. If not, we'll have to make a friction clutch, which might be fun. But we'll just try slipping on some teeth to start with. So, yeah, so I'm going to have a little break, and then we'll punch this through here. We'll put a mechanism on here, down to the motor. I'll see you in a second. Right. So what we want to do then is we have the motor. We have a motor that we kind of probably want to model some of it. And that's going to help us align the holes. So let me see if this camera is not working. Let's try again. Ran out of battery. Okay. Okay. Just give it a minute. What if we come back to it? No. Oh. Here we go. So we have one of these motors that we want to mount to this part here, right? So what we'll kind of want to try and do is we'll try. Oh, let's move that back over there. Is we essentially need to work out where the holes are, and then we'll find a sketch of this motor model. We'll sketch it out, and we'll make a somewhat crude version of it, just so we can see where things fit. It's probably the easiest way. Spending some time to make a model of it. You can get models off part websites, and that works fine. I did that with Fusion. However, in FreeCAD, I haven't found a reliable way of converting it to a model that I can then use. It always comes in a mesh that's well too defined, and if you try and draft and reduce it, it doesn't really work or it crashes. So it's probably easier if I just take the sketch off a website, resketch it, extrude it out, and then extrude a shaft onto it as well. So we'll be taking this. We'll start with this face. We'll find a proper dimension sketch on the internet, and then we'll extrude out a shaft like that. And then that will allow us just to double check all our measurements, and have a somewhat confidence that it might work. Cool. So what we'll do, what we need to find first is a schematic of this motor type. So most parts will have in their data sheet what the front face of a motor will look like. Okay, so this is a 1308. Just bear with me a second. Okay, so what we'll do, let's start by making a new body again. And really, I don't want to spend too long on this. I just want to make a very crude mock-up. And we'll say this plane here. And we'll go ahead and hide everything here. So what we want to do, having a look at the sketch itself, it's 396 round. So let's make a new one, 396. Whoa, okay. And then I wonder if we can kind of want to show, can I paste that in here? Something like in Fusion, you can like import an image as a background. Not sure whether you can do that in Visual Helpers. No. What we could say is, can I add an image there? What we're just going to do is, let me just take a screenshot of this. And we will I'll pop that in there. There you go. So this is kind of what we're gonna try and aim towards. Hopefully, it doesn't need to. We just want to do this front face here, but that just kind of gives you an idea of what we're trying to do. So we have this front face which is 396. Or is it 39? It's 39.6, isn't it? Yeah, that's why that's so big. 39.6. There you go. Right. So if that's 39.6, we then want we can see kind of, if we have a look at the left sketch, we can see there's a cross and then there's some screws that are M3. Okay. And they are on an arc of 31. So what I'm going to do first is put in a construction line that is 31. And then all our screws are going to fit on this construction line as the center of their circle. We then have, and I'm just going to check in real life. Yeah, that looks reasonable. So we're going to take a proper circle. I'm going to origin that basically there. And that's saying an M3, so it doesn't really matter for these purposes. I'm just going to put 3.1. And then we can see that it's not constrained properly. So we'll come in here, click that, and do a coincidence constraint there. So that's going to bind. It can move along this face, and it can move along here where they intersect. It will go there. So we'll do the same here. So we're going to click that and click the origin, and then do a coincident. Okay, so that has those two screws, and actually they're the only ones we care about. If we have a look at the motor sense amount, we need flexibility in the vertical axis. So we only really care about these screws. The other ones are in a bit of a, not in a great position. I think that will be fine. Let's go with that to start with. Yeah, I didn't want this to be too complicated, so we have these. But before we go any further, we'll just make some, because we have these sketches here, we will make a how the shaft should work. So the advantage of doing it at this point is I can then project this sketch into further sketches. So, so what we'll do is let's take a circle, and we need to know, based on the diagram I've just shown there, it's going to come out 5.5, and I'm just going to double check that on using the calipers here. Yeah, it comes out 5.5 on the kind of the thicker shaft, and then we have a thinner shaft there. So we'll do the thicker shaft first, and it's going to say how wide is that shaft. It looks like 12 based on the diagram, and we're just going to confirm, yeah, it's 12. So we're going to put a 12 mil in there. Okay, now that looks massive, but we're going to make the inset here 7, I think. So from the origin, if we have a look in the diagram on the bottom left, we have from the kind of the center point to the midpoint of our big circle is 7 mil. So that's that. I'm going to make those a construction line. Again, I'm going to use them in a second. And then we're going to have our middle part, which is 5.5. And again, let's just double check that. That's 6. Yeah, okay, 6. So we'll just do a 6 there. La 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 la. Cool. Okay, so that kind of looks like a motor, right? If we extrude this out, this is going to be our front plate. Just for modeling purposes, we'll extrude it out to be like 8 mil. So pad 8, fine. Okay. And then what we'll do is we have this sketch. I wonder, that sketch is still visible. Ah, we can't see the construction lines. Okay, well, that was a waste of time. Ignore what I just did previously. Yeah, we have the origin, so this isn't actually too much of a drama there. 3.1, 3.1, that's fine. We have the origin here, so what we'll do is we'll take this, we'll attach it to that axis, and I said it was 12 mil, didn't I? So we'll do 12 there. I guess we need to do actually this in 2 sketches. Something in Fusion 360, what you can do is you can extrude out different parts of a sketch. So you could do it all kind of in one sketch, and you could say, oh, I want this face to be X, I want this face to be here, this face to be here. FreeCAD actually limits you to a sketch must be a single face, which is, you just end up with a lot more sketches really. But yeah. Okay, so let's say that's 12 mil. No, that's 7 mil. Okay, and then we'll extrude that out, and based on this, it should come out 5.5. Okay, and then we'll do the same again here. So here we can do a projection. We want a construction line projection. Again, a feature only available in FreeCAD 1.1. And then we can extrude this out. And I think I said that was 6 mil, and I'm just going to double check that. Yeah, that's 6 mil. And it comes out 15. Yeah, the diagram says 15, so that's fine. So you can see here what I've done is I've projected this circle to get midpoint, and then I've drawn a circle on the midpoint there. Cool, so now let's pad this out 15. Awesome, so that's now the front face of my motor. Pretty simple, it's just all we need. And without going through the pain of trying to import something into FreeCAD that I have not worked out. So what we will do now is if we pop everything back in here. So this is essentially going to sit on that face. To start with, I'm just going to transform this to this side. Okay. And then we're just going to move it down. And we're just going to see, how does it kind of work? I don't know. Okay, so I think the first thing we can kind of, let's just leave that there for a second and we'll just move around. So this is going to be a problem, isn't it? So we've made this kind of intentionally thick, but the shaft isn't particularly long. Okay. So what we might have to do is have an inset, have like an elongated inset. So it has a flush face. But still has the rigidness. So if you were to take this in PET G, but only make it 5 mil, this will bend. Let's just check. So it's 10 centimeters. That will flex given any. As soon as you put a bit of tension down this face, it will start flexing. Even 1 centimeter will probably start flexing. So this is 1.5 centimeters. So it has a bit of rigidity to it. We could go bigger if we wanted to. So I think what we're going to do is let's punch this face through so this can sit inside. And then we'll take a screw back this way to fix it there. What we'll then have is this will hopefully, the burger alarm's going off. 1 second. Right, so yeah, so if we have a slotted inset to this, it can then move up and down, and hopefully there will then be enough shaft, which again is adjustable. But we need enough shaft there so when we mount a sensor to the end of the pole, it will work. So what I'm thinking of doing, if we just have a look at that end on, yeah, perfect. So this is kind of what I was hoping to see, that they're mostly aligned. We just need to tweak that a bit, don't we? It's not perfectly. What that was just a crude measurement based on just some calipers. So what we'll do, let's have a look at the sensor mounting mount. I'll edit this here. Okay, so I think what I need to know is if we have a look at the motor, what is the measurement between these 2 points? We're just going to steal this for a second. So that's 31 mil. Cool. And then we can go back to the sensor mount. Here we go. So yeah, here. So I said 30. So if we take what 15.5 should then work. That should give 31 mil separation between the two. Cool. If we then close that, that looks now correct. This is still in the center, fine. These gaps are probably a bit big, aren't they? What have we got? We're saying a radius of 3.5. Now the holes are M3s, which means it only really needs to be 3 mil. Maybe a radius of 3.1 or 1.55. Just see what that gives us. Let's try 1.6. And it doesn't matter too much around like this, as the 3D print will give you something close to it, and as long as the bolt can fit through there, that's kind of all you can really do. As long as it's not loose, we can put a washer on the front of that and then kind of drill that in. There is a limit on these, how far you can put the screw in. There's a solid back plate, but as long as you find something that is a suitable length, that should be fine. Okay, so that looks fine. We now need to kind of cut a pad out, which would allow more of the face. So how do we do that? Do we just, we could either cut out a massive slot that's adjustable. That's probably, or we cut out a whole edge, but then that kind of causes a bit of a stress point here. So I think let's go the massive slot approach to start with. So we have 39.6 for our diameter. Let's increase that to 40. I'm going to hide the motor here. I'm going to make a new sketch. Let's make sure we are selected into the right thing. A new sketch on there. Cool. So we then want to make a slot. So we'll use this tool here. And again, we'll go down the axis. We always love axes. Axes. It's not really what we want, is it? Or is it? No, I think it is, isn't it? So, So between there and there, we want 40 essentially. Um, let me move that. Ooh, that up maybe. What's this getting upset with? So I guess the alignment that I have there is kind of unrealistic. Maybe what we could do is just something like that. So you can move it up more. Okay, so what we could do, let's project this line here. I'll make that a construction line, and then we'll attach these points to it, and we'll make that coincident. It's saying one of those is probably redundant, isn't it? Because it's constrained in multiple ways. I'll do. Okay. So at the top of this, so it's going to look like that, isn't it? So I mean, if we do something like that, that is going to be plenty high enough. So put this out here. Let's just call this 35. I don't think it's going to matter too much. But let's just do this to start with. This is 15 thickness. So whatever we don't have, 15 thickness is basically is most of the bar, right? We have a 20 bar. We probably want 5 left. So I mean, if it's too weak, we can come back to it. But something like this, I reckon, it might work. It might work. So let's transform that into this face again. I was just going to do a bottom view. Yeah, that's fine. Okay, you can see here now we actually have a decent amount of shaft. If we were to move this face up, nice. So we still have clearance. And if we were to move it down, then it's just going to come out the bottom. But we, oh, okay. What's the limit that we can move it down to? So that's that 7mm offset that I hadn't accounted for in the original sketch. We don't really want to cut this out. That's going to be quite useful. I wonder whether we just put these up 7 more mil. Might be the solution there. So if we take this, and I don't know, these currently aren't constrained. So if we do something like 15 plus 7, and have them go up that way, let's just see what that currently gives us. La, 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 la. Okay, so this is now kind of a collective bar. There's a pivot mechanism up here for anyone new joining. A better example, actually, let me show you what this looks like from a larger point of view. So so this is a chair. This is the collective, so a collective in a helicopter controls the angle of the pitch of the blades. But it also contains a throttle mechanism in a twist fashion. So similar to like a quad bike or a motorcycle type thing. If you twist the throttle, it's going to increase the engine power. So you raise it up, lower it for the angle of the blade, and the throttle is a twist action. Now, in a helicopter, typically they have something called a governor, which will control the throttle of the engine, so that twist action, based on the needs of what you're doing. So if you lift the collective up a lot, to maintain that to retain the RPM of the blades, you need more engine power, right? And then you'll lift up. So what we want to do here is we're essentially making this throttle mechanism. We're going to have a bar that goes, a control bar, and then a mounting point here. And we're going to hope that nothing collides. So this is what I'm doing in this assembly here. So I have a throttle that essentially, that has some gears here. As I rotate this left and right, it's going to go through this gear, which is fixed to this bar. We're going to put a sensor on the back of here and a AS 5600 mounted here. And then this bar is going to join to this bar with some form of slip mechanism that I haven't thought through fully yet. So when the governor wants to change the throttle position, it will do so via this motor shaft. But if the pilot wants to change it, so when I want, say, 0 throttle, I should be able to override it using the twist mechanism there. So the idea is I can twist 90 degrees. This is the input axis that will show through the game controller. And then if the simulator governor wants to change the throttle position, we'll feed that back through this motor through a friction clutch. So let's see what happens. Okay, so what I've done is I've insetted this, and we'll just hide the motor. Let's just bring that back again. Ooh. And we just want to check kind of the freedom that we get here. So that's fine. We could make those screw holes 7mm offset, right? So they're the same height, they're just offset by 7mm based on that motor diagram I have on the screen there. So if we go back into this sketch, yeah, I guess here to here, but diagonally. So what we'll do, they're the same height, they're just 7mm. Right, so actually, so these are 15, aren't they? But if you move them up, and then you do a differential height there you go. So I think that's what we want. Get that measurement there. Right, so now if I move the motor down, so this is why it's useful just to kind of have a little of a mock-up of the motor itself. It allows you to view how things are going to work. Yeah, that's cool. Look at that. So if we have the lowest position, so if we want to increase the tension, we'll move it down. If we want to loosen the tension, we can move it up. There you go. So I'm quite happy with that. And if we have a look on the side profile, that looks pretty good. We have enough shaft there to work with. Okay, I'm just going to save that. And what we'll do is, so we can put the bars in there, we can put that in there. What do we want to do now? So this is probably in the way, right? We're going to have a lot going on here. So I'm just going to shift this back a bit, and really this is just a support. It doesn't really have, it's just so this doesn't twist at all. This is supporting this, and then this will be closer here. What we need is a cog around here, which is going to go onto a timing belt, which will join these two rods together. What we're going to do to start with is to kind of ignore. My initial plan is that if the belt's going to be loose enough so it can slip, if that doesn't work, yeah, we're going to have to make a friction clutch. But I think let's try in the easiest approach to start with, and then we can make a friction clutch if we so require. So what we have is a belt. So this belt here. So that's gonna one end's gonna go on the motor, one end's gonna go on a new cog. So it's not actually that long, is it? So let's just double check our measurements. And we do also want to fully constrain that sketch as well. So if we take that length, now this doesn't take into account what cogs would look, what the kind of ends would be. So if we say something like that, it's around 80. So that's 80 mil. So really, it's going to be less, isn't it? So maybe 70. Let's work with that to start with. We can always do some more measurements as we go. So so we have our collective arm, we have our throttle. That's going to drive here. What I want to do first is we're going to go into the motor sensor mount, and we're going to edit the sketch, and we just want to constrain this down. So let's start moving stuff around. Okay, so we could still adjust this. So what we're going to do, let's pin this to the axis. Let's pin that to there to start with. Let's say 11. Okay, cool. So that's now fully constrained. So that's going to give us our adjustment for our motor. Cool. I'm happy with that. And we can move this, once we've done a cog on this rod, we could move this sketch up and down and adjust that as we please. That's fine. What I'm going to do now? No, let's do this cog. So we have a mechanism here, and then that's going to go up to a timing cog. So we're going to have a bit of fun. We'll go into the assembly as go into the assembly. So we don't want, right click here, uncheck active body. When we make gear, we don't want it to be part of a body yet. So we're going to go into the gear workbench. And I haven't actually done a timing gear in FreeCAD, so let's see what happens. Okay, so we have a timing gear over here. Oh, and let's zoom in on that. Okay, that doesn't look too bad. So what we'll do, let's have a look at the timing gear. So we get the properties down the left here. Awesome. So this is saying it's a GT2. We have a GT2 belt here. And we also have a 200-GT2. let's just double check if there's any bits that we need to be aware of. So it should be 200 long. That's correct, right? We measured it was 94-ish. So yeah, so it's 200 long. It has a 2 mil pitch, which is the GT part. And it's how wide is this? It's 6 mil wide. Cool. So now the number of teeth. The number of teeth is going to affect the gear size. So if I set this to 30, it's going to make it a lot bigger. If I set it to 15, it's going to be that. So we do have one of these, which is the same thing but metal. And that does fit quite nicely on our motor shaft. So we're going to use this on the motor shaft. It has a 6 mil bore. Really, I need the same number of teeth, I think. It doesn't really, it doesn't matter too much. So the bar itself, if we rotate this 90 degrees, this will go less than 360. It can't rotate multiple times. I think it's probably around 180 to 270 degrees. So this will rotate 90 degrees, this will rotate, let's say 180-ish. This is quite a high torque motor anyway. So really we just need it big enough to fit on the bar to start with. And we can tweak it as we go. It's probably the way to go. So let's have a look here. So we have a number of teeth. Let's call this 20. Yeah, I think 20 should be okay. And the height of it would be 6. Should be fine. And we could put some flat faces on the edge of it. I'm just going to have a look at my metal version. So that's actually 7. So let's do 7 and then we'll put some faces on the edge. Okay. And then we're going to take, what we'll do, we'll move that into a body. Because, yeah, that's fine. So we'll move that into a body. And we'll call this GT2 gear. We'll move that in. And it's going to say, no, you can't do that. Yeah. Okay, that's fine. How many teeth we said? 720 GT2. So let's just delete that, delete that. Let's make a new body first. And then once we're activated in the body, we'll make a gear. Timing gear. Go into the timing gear. We wanted that 7mm 20 teeth. And then we're going to move that out there. Make a new sketch on here. And then we're going to extrude this out 16. Sure. Yeah, let's go with that. And we're going to pad it 1. Okay. And let's just do the same on this side. You know, we could faff around and mirror that, but I can't be asked. So what we're going to do is we are going to project that like that. That's probably the easiest way of doing this, isn't it? And have that one melt. There you go. Cool. So now the shaft through the middle of it. So we're going to make a new sketch here. And we're going to make the shaft 5.1. Cool. And then we're going to pocket through the shaft. We'll just do that. Yeah, that's cool. Okay. So something I haven't taken into account here is how we're going to actually attach it onto the shaft. So we need a bit of a dome or a bit of a hub as such. So I'm going to make a new sketch on this side. We'll do the inner hole. So again, I'm just right clicking there because I started doing something I didn't want to do yet. This is going to be our inner edge. We're going to have our outer edge. Let's call it 10. I'm going to pad that out. 8. Yeah. Now we could keep that the same width. It's probably... So I could just pad this out more, couldn't I? Yeah, let's do that. So on this, on one of these pads, it really doesn't matter. We could pad it out by 10. There you go. Ooh. Right, and now we take a face. New sketch on ZY. Okay. And then probably the easiest thing to do is that. There we go. And then we pick something there. We say that's 5.1. Then we say that's 5. Cool. And then we pocket that. Up through there. And we've kind of done that wrong, actually. We need to do a hole in that. So what I'm going to do is just, I like doing it this way. Just delete that pocket. So see, I've just made the sketch there 2 mil, not 5.2. And what that means is when you do the hole, you can see that it's actually done it correctly. If you were to make that 5.2, it's sometimes not particularly clear whether it's trying to screw you over or not. So we can turn that off. But I mean, that's drilling out there. That's perfectly fine. What we need to also do is model the threading type. And honestly, the threads that come out of this and get printed are reasonably good. Again, we're not putting major loads through this. That will do, I think. It's a bit messy there, but that should kind of work. And we can see this sketch we had here that we can actually delete and run. Cool, so that's going to be our gear. We notice that that's not gone through there correctly, so we'll just edit the pocket. There you go. Okay. Right, let's just save that. So we want this sitting on the bar over here. I think the easiest way of doing that is we use the assembly and then we offset. So if we go into the assembly, we want it fixed. It's going to be fixed to the bar. we want that face, and it's gonna get on the end of the here, isn't it? So something like that. We'll rotate that, and then we'll offset it just slightly. Doesn't need to be fully. If we look at it from a different view, maybe the other side. Okay, so something like that would be fine. What this is really going to depend on is how we mount the sensor here. It should be possible. It would probably end up actually mounting it somewhat flat. So we can push this up as close as possible. What's the distance between these 2 points? Let's just check that. 4 mil. So not that much. But again, that's adjustable. So once we put a magnet on there and the sensible, that's going to get a bit close. So this is going to have to spread out. It should be okay. I'm not too concerned about that. Okay, so we have a pulley there. Now we're actually going to use, it's going to kind of be the same pulley, isn't it, really? So I'm going to go in here and clone this. We need the part design workbench, and we'll do a clone. And let's call this GT2 motor pulley. Okay. And then we'll move that into the assembly. We'll activate the GT2 motor pulley. And really, it's part of the assembly now, isn't it? So let's activate the assembly. And we'll say GT2 motor pulley. We'll just move that for a second. And then we're going to say, I want it to be fixed upon something like that, something like that. Ooh, wrong thing moved. Okay, try that again. So we want, we kind of did it that way around, didn't we? And that moved there. Let's just try the other way around. That's what we want. And then we can flip it. And then we can offset it. Right. Cool. So that's now definitely not aligned, but we can flip this side. So we can take this one. Let's just have a look at the RGT2. Where's it gone? Where is it gone? There you go. And then we can kind of line those up. So again, in real life, we would just work out how to make that work. I don't think this is really the end of the world, is it? Because if that lines up to the end of a shaft, so in this case, we just make the shaft a bit longer, then we can put a magnet on the end of this shaft and measure a rotation on it. Or we can flip it and move it that way. Maybe that's probably the better idea. Okay, let's do that again. So we'll flip it and shift it off that way. Something like that. Cool, so then we have the belt that goes through it. And then we kind of want to move this a bit closer like that. So this one will be metal, this one will be plastic, and the idea is that we'll get some slip. Okay. So if we measure from here down to here, bum, 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 bum. That's 40 mil. Now we can't move the rod. I wonder if the belt I have is going to be too long. Right. So we have this belt here. This is going to be a very similar pulley to what I've just made. So really, what is that's going to be the axis height. Yeah, it's going to be around 70, isn't it? We have 40. This is the smallest belt I have. So really we want a 40 mil belt. Or it's not a 40 mil belt though, is it? It's like 100 mil total length. Okay. What I don't want to do is make this too unnecessarily long. But it might have to be a bit longer than that. So, okay. What we'll work on now then is we know where this bar comes through. And we'll take the motor sensor mount and we'll give that a, aiming for a color. Or let's just close that tool. Let's just give that a new color. Okay, cool. So the mount's going to go on there, and the sensor's going to go in here. Let's just save this. If we go into our cyclic gimbal. Okay, we have one of these. So this is a sensor. And we kind of want to copy that. Yeah, I don't know how well this is going to work. Okay. And then we go into the collective throttle assembly. So again, this is just a quick sketch I made so we can see how things perform. Oh, it worked. Okay. Nice. Okay, so we actually have a sensor body here. What we can do is we'll call this That's a sensor. And this also has kind of the sensor chip, the AS5600 that we'll be using. And what we'll do, we'll move this down. I wonder whether it needs to be attached. It does need to be attached, and I'll show you why in a second. So the reason we've put this extra this circle on is so we can align it directly to this edge here. So what I'm going to do, I'm just going to hide the mount, and we can hide the motor. We'll get the mount back in a second. I'm going to activate the assembly. Go to the assembly tool bench, activate the assembly, and then we'll do a fixed joint based on that. Really, it just needs to be in alignment, doesn't it? It does. Let me just pull this into the assembly anyway. I wonder what's the best way of doing this. Okay, well let's make it a. No. Let's try again. Nice, nice. Okay, so this is kind of the idea I'm going for. Give it a bit of an offset. So I realise what I've just done there is I am still binding this to this. But what I could do is I could make a sketch out that is somewhat flexible, up and down. It's going to be perfectly in the middle of this bar. I'm not concerned about that. What I'm concerned about is if this bar needs to go up and down for this gear meshing. So what I need to do is allow this mount to, or essentially cut a face out of here that would just allow this sensor to go up and down. And then when we're happy with the place for it, we can use some hot glue to stick it in place. Is probably the sensible approach. So we know this is going to be centered on there, so we can just kind of draw a square up. Inset it. But we also have this inset here. Ooh, that's going to cause problems, isn't it? Maybe the solution is not to inset it. However, like, mean, that would be fine. The bar would have to be slightly shorter. We could still put a magnet on the end of here. This would essentially be glued on. I mean, that's probably going to work fine. What we could do is extrude some vertical lines for center alignment. That's probably the most sensible thing to do. So I'm going to take out the end bearing, and we only have a few minutes left, so what I'm going to do is I'm going to edit this face. So I'm going to wrap things up in a second. So we're going to edit this face. Let's just turn off the transparency. We're going to make a new sketch here, and we can see way too much stuff. So we kind of want the rod. Get rid of the pinion, and we'll get rid of these mounts. Cool. And then what we want to do, we want to make some form of support. Pretty crude, but it'll do the job. And it just gives this some horizontal alignment, because we can guarantee that the bar will be in the center. So if we make this something like 11.5, it doesn't have to be interesting. So this face here, if we rotate it 90, this component isn't perfectly square. Sure, that won't be either. Okay, maybe we'll leave that there and we'll just work around it. So okay, cool, that'll do. Make this 2 mil, make this 2 mil. We'll make the length of it for 2. And they'll bind it to probably just to this will be fine. Cool. So this will kind of just give us a bit of this will allow us to put the sensor in a place where we can adjust it slightly. Now there are some wires and stuff that go through. We're going to have to check this. It's either this edge or this edge, but we're going to have to get the sensor out and just check which edge we need to allow for, because we might need to actually rotate this 90 degrees. So there's some resistors and some wires that we need to allow through there. So that's fine. We'll tweak that. Then we have the motor. It's going to go onto there. So that's looking pretty good. Pretty good. So what I'm going to do now is I'm going to print this part. I'm going to print a new cog. So we can test these parts. I think I'll probably print a bracket as well. And we'll maybe print this part as well. Cool. So I'm going to end the stream there. Tally ho.